Vacation plans, long commute, weekend at the cabin. Wherever you end up this summer, the Connector Idaho Daily News helps keep you connected to Idaho, even while you're away. Get the top local stories every weekday morning in just a few minutes. That's the Connector Idaho Daily News. Listen on your podcast app.
I'm Samantha Wright, filling in for Gemma Gaudette. You're listening to Idaho Matters. How do you find alien life? Well, first you need to find planets that might be able to support life. And that's not always as easy as it looks. Scientists have been able to find a lot of planets orbiting distant stars known as exoplanets. These are often big Jupiter-sized planets that are relatively young. And now they're hoping that the Nancy Grace Roman Space Telescope will help them find smaller, older planets that might be able to support life. The telescope is set to blast into space this Sunday on a SpaceX rocket from the Kennedy Space Center in Florida. Dr. Jason Rhodes is the JPL Roman project scientist, and he's coming to jump in Boise on September 26th for Interplanetary Life March of the Robots. And when we heard about March of the Robots, we just had to know more. So we asked SpacePoint if they could help us get in touch with some of the people involved with the missions. And they connected us with Dr. Jason Rhodes and Kyle Averill, the president and co-founder of SpacePoint, to talk about the mission. They're here. Hi to both of you. How you doing today?
Great. Thanks for having me. This is Jason.
All right. Samantha, it's Kyle. Thanks for having us.
Yeah, thanks for coming back, Kyle. Jason, tell us about this Roman Space Telescope. What is it?
So Roman is NASA's next big, what we call flagship space telescope. These are the big telescopes that take decades to plan and build and are going to transform our understanding of the universe. The last one to launch was the James Webb Space Telescope a few years ago, and we are just about 6 days away from launching Roman, a telescope I've worked on for the last 24 years.
Wow. Okay, so no time investment there.
Yeah, a little one, yeah.
Just a little one. Okay, tell us about what the telescope is going to be able to do and why it's different from other space telescopes.
Well, at the heart of Roman is a camera called the Wide Field Instrument. And what this means is it's a camera that has a very wide field of view. It can look at big areas of the sky all at once. In fact, the camera, due to advances in detectors we've had since the cameras were built on Hubble and even the James Webb Space Telescope, it can look at about 100 times more area of the sky at one time compared to Hubble or Webb. And so that allows us to survey big areas of the sky, or in the case of one specific survey that we want to do, not a very big area, but we're going to look at the center of the galaxy, which is very rich with stars. And we're going to look at that center of the galaxy over and over and over, and look at millions of stars for weeks on end. And we're going to wait for those stars to blink. And once those stars blink, if there's a very telltale sign in that blink of the star, it tells us there's an exoplanet there.
So why are these exoplanets so important? And, we've been hearing a lot about exoplanets over the last few years. We seem to keep finding them. So why are the ones you're going to find a little different, hopefully, and maybe might help us find life?
Yes. So Roman is going to have the ability to do some different techniques than we've used in the past to find exoplanets. Most of the exoplanets we've found, and we found about 6,000 exoplanets over the past 30 years, most of these have been through a technique called the transit technique, where you wait for a planet to go in front of its star, that is, transit in front of the star, and you see the starlight dim a little bit. And this tells us that there's a planet there. But this is most effective at finding very large planets that are very close to the star. And when we want to look for planets that are more like Earth, smaller planets that are a bit further from the star, this transit technique won't work as well. Now, Roman will be great at this transit technique. It's going to find another 100,000 planets on top of the 6,000 that we already know about using transits. But it's going to use another technique where two stars pass in front of each other. And if the front star has a planet, that causes a blinking in the light of the background star that tells us there's a planet. And this technique is called microlensing because the closer star acts as a lens for the further star. And this microlensing technique allows us to find planets that are smaller and further from their star, like the planets we have in our solar system, like Mars and Earth. And so it's going to be really key to finding out how many Earth-like planets there are and really completing what we call a demographic census of the planets. We know about the big planets and the close planets, but we want to know what's the probability of finding smaller planets and planets further from stars. And this is really going to help us understand that by finding thousands of planets in areas of solar systems where we've never been able to look before.
Okay, did you say maybe 100,000 planets you're going to find?
We're going to find 100,000 planets. Most of those will be with the transit technique that we've already used before. But a couple thousand of those planets are going to be with this different microlensing technique that are going to allow us to find a whole class of planets that's really been invisible to us in the past.
Are you excited about that?
Oh, I'm incredibly excited. It's a really exciting time because we're just starting in the last couple of decades to understand about exoplanets. And this ability to find so many more is going to allow us to do all sorts of statistical studies of those planets and bend them into different types and different distances from their stars and really understand how planets form and how planetary systems evolve.
We're speaking with Dr. Jason Rhodes. He's the JPL Roman project scientist, and Kyle Averill, the president and co-founder of SpacePoint, about March of the Robots coming to JUMP in Boise on September 26th. Kyle, remind us about March of the Robots. What is it? What's going to happen?
Thank you very much, Samantha. Well, hopefully listening to Jason, you get a flavor of the type and the quality, the expertise of the talent that's going to be joining us. So Jason will be kicking off the event. We have 4 other experts who will be speaking after Jason. We also have a career panel. These are careerists that are out there working in the industry today, early careerists that are working in the industry today from organizations like United Launch Alliance, Stoke Space, of course, NASA, Houston, and so on. But it's an all-inclusive event. So not only do you get to actually not just hear from Jason, but you could meet him in the first hour with our meet and greet after the doors open. But it's when I say all-inclusive, I mean food. There is a science fiction movie that we're going to show. We like to have a little fun after all of the more serious topics. So we can't talk about what movie that is because we'll violate licensing rights, but I will say it's a very recent movie and very topical. And then, of course, there's stargazing with Boise Astronomical Society on the deck at the end. So, and we're also have what we call an Advanced Space Academy Challenge. So basically, you come to the event, you hear these presentations from these brilliant people, frankly, and you take a quick quiz. And if you finish in the top 3, then you're going to go to Advanced Space Academy in Huntsville, Alabama, for a 1-week all-inclusive experience.
Oh, wow. Okay, that's cool. All right. Jason, when Kyle told me that the telescope was going to launch this Sunday, I thought, wow, that's great timing. But I also thought this has to be a very busy week for you. What are you doing this week?
I've got a few meetings today and tomorrow, and then Wednesday, I fly to Florida with my wife, who also works on this telescope as a cosmologist studying dark matter and dark energy. And we're bringing our 3 kids, so it's going to be a family affair. And my wife and I have some interviews and other things lined up, but we're really looking forward to watching this launch and having our kids see a rocket launch that we've worked on for so long.
Wow. Okay, so it's going to go up into space. And where does it live in space, or does it move around?
So it lives quite far away. And this is one of the real benefits of Roman compared to, for instance, the Hubble Space Telescope. Hubble is in low Earth orbit. It's quite close to the Earth, just a few hundred miles. And that means it's going around the Earth every 90 minutes. It's going in and out of the sunlight. But we are sending Roman to the Earth-Sun Lagrange point 2. That is a point where the gravity from the Earth and the gravity of the sun equalize, and it's sort of a stable place to put this telescope, and it's out beyond the moon. So it's 1,000,000 miles away. And this is a very thermally stable place. So the telescope can sit there in the dark, in the cold, and just make its measurements for years on end without the sun or the Earth bothering it.
So when are you going to start getting results back from Roman?
After we launch, which again, I hope is in about 6 days, we'll first, we'll be traveling to this L2 1,000,000 miles away, but we'll also be doing a number of commissioning exercises to test the instruments, turn everything on, make sure everything works. And we expect our first beautiful images to come out right around the beginning of 2027.
And what are you going to do with all that data? You mentioned you were going to start sifting through it. That's a lot of planets to try and figure out what to look at next.
It is. And one of the things that's really great is this telescope is coming online and just a deluge of data, thousands of times more images and thousands of times more pixels than we get from, for instance, the Hubble or even the Webb. But we've got a lot of progress in the last few years on using machine learning and artificial intelligence to really leverage our scientific abilities to handle these very large data sets. So we're going to be depending on computers that we train to help us find and classify these planets. And it's really interesting that the telescope technology has come along right in lockstep with this computer technology that's going to allow us to really capitalize on this huge data set.
Wow. Okay. Good luck with the launch on Sunday. And Kyle, I've got about a minute left. Can we still get tickets to March of the Robots?
Yes, absolutely. Spacepoint.org, very simple. You go right to the landing page and you can get tickets right there.
Awesome. I want to thank you both. And again, good luck, Jason, with the launch on Sunday.
Thank you very much.
We've been speaking with Dr. Jason Rhodes. He's the JPL Roman Project Scientist, and Kyle Averill, the president and co-founder of SpacePoint, about March of the Robots coming to jump in Boise on September 26th.
You've been listening to the Idaho Matters podcast from Boise State Public Radio. To stay in touch, you can find quick Idaho Daily News every morning when you subscribe to the Connector podcast. If this podcast has become a part of your routine, can you tap 5 stars and leave us a review? It helps us stand out.